Going on to the last section that will be in our curriculum of Math 1103, Section 6, Dividing Polynomials. So as we look at it, if we were to see A over C plus B over C, you might say, well, what are they doing here? Well, this is addition of fractions. And what we are doing then is adding our numerators, putting them over our common denominator. And that, in a sense, is how we would simplify if we were adding. Now, if we wanted to divide, and we had something like this, and they're saying, now divide, the strategy would be to take it from this form and put it back into this form. So, the strategy for dividing a monomial, which would be our denominator here, into the items in the numerator would be to put them each over your common denominator. So go from this model to this one, and then you simplify each of these terms. Okay, so let's take a look at an example here. We are going to do some division. And here we see a fraction, two terms in the numerator over our common denominator. So we put each of these terms in the numerator over our common denominator, and we start to simplify. So 2 goes into 6 3 times. There's a 1 there that we subtract, and we end up with that, and this is just something over something. That's always a 1. Now remember, this doesn't disappear and become nothing. It's a 1. Okay? So let's do the example they give us down here. So the procedure would be to put each of these divided by our common denominator, and then here the 4 cancels and you end up with a 2 here. T to the second up here becomes a negative 2, so that becomes that. And here these are identical, so that just becomes a 1. Okay, that was not too bad, and we're moving along. Example 2. So as we look at example 2, again, it's a trinomial now that's over a monomial. And our strategy is to take each term of the numerator and put it over our common denominator, being careful of the signs, and then doing the division, watching the sign. Now here something interesting happens. The 3's will cancel out, and in a sense there's a 1 left up in the numerator, but to keep your exponents positive, we're going to bring this x to the first down, subtract it from the 2, and we have an x left in the denominator. So this part here is critical, and where students can often make an error. And you'll be doing some practice on these. Now in example 3, again the technique, each of the terms in the numerator we put over our common denominator, and then we cancel. So these are problems we had in an earlier lesson when they're in this form, and you're just simplifying. And notice here in the last term, you have something left in the denominator. So an interesting observation might be at this stage, and this is just a reflection back to what we did earlier. Is this a true polynomial? And the answer is no. And do you know why? Because there is a variable in the denominator. Okay? Now, they're going to broadly classify these as polynomials. And anyway, so again, I find that as an interesting observation. All right, let's go on. Now, looking at this example, just as a concept check, let's take it as we see it. So it's x plus 5, and then again, you put it over 5. So this simplified will be x over 5 plus 1. So this is the correct answer. Again, some may say, well, the 5's disappear, and you know, these are both incorrect here. Okay, a thought. And again, you'll have practice. What I want to feature here is the technique in getting the correct answer. And the technique is just converting it from this form to this form, and then simplifying. And your practice will be your mastery. Now, the part that's often challenging in division is when we have to do what is called long division. And here they're taking us back to our basic pattern of doing the old-fashioned long division. That since we have the abundant use of calculators, we don't do this anymore. But in algebra, you need to be familiar with this system. So, does 13 go into 3? No. 13 go into 36? Yes. How many times? Well, you might say 3. It would be too big. So you say 2. 13 times 2 is 26. Now, what do we do here? Well, we actually, let me get a pen. We actually are going to subtract. So where that used to be a positive 26, to subtract it, we're going to indicate. Now, we just knew we had to subtract. But in algebra, that gets a little bit unclear. So we have to change the sign. That's now negative, and we just add. And then we bring down the 6. And then 13, we have a trial divisor. Goes into there 8 times. We get this. We get this. Bring down the next number. Multiply. And we end up with 7 as a remainder. So we put our 7 over 13. So the answer is this and that. Now if we multiplied 13 times this and added 7, we'd get that. Okay, well let's go on to see how it's done in algebra here. And that's just finishing up what we showed you. Now I'm going to work this one over on the side for you so you can see how it's done. So all I've done is I've copied this example in the form of long division. So we put this out there and this under the division operation sign. Now, the rule is x will go into our first term how many times? Well, this one's easy, but if you ever had trouble, you could always do this. X squared divided by x. So we put this on top, this on the bottom, and simplified, that is just plain x. So we put our x there. Now, we're going to multiply. X times x is x squared. 3 times x is a positive 3x. Now, here's the key. We're going to put a line underneath this, and what do we do here? We subtract. We subtract by changing the signs and now adding. So these just cancel out. Or you could put a 0 or just don't put anything there, but they cancel out. Now here we have a 7x minus 3x gives us a 4x. Now we bring down our 12. And again, we want to say x goes into 4x how many times? Well, you could just go like this. 4x divided by x, the x's cancel out, and you are left with a 4 up there. So x times 4 is 4x. See, this is what you want to do. 3 times 4 is 12. Now again, you're going to change the signs and add. So this becomes a negative, this becomes a negative, and everything cancels out, and there is your answer. Okay? Now they have it all described here, and if you, again, FOIL this, you would get that. Now I'm going to do example 5. Example 4 is sort of an easy one here, the practice. So let's do this one. Now they have it worked out here, but we'll show you the process. So again, you want to say 3x goes into there how many times? Again, a technique would be x squared divided by 3x, and you're simplifying this, and this goes 2x times. This simplified becomes 2x. That's what you're going to put here, because now 3x times 2x gives you 6x squared. Then you take this other term, a negative 1 times 2x is a negative 2x. And once again, as you put your line underneath this, you have to change the signs so that you can subtract. Because in algebra, how do we subtract? We change the signs and add. So this becomes a 0. This will be 12x, and we bring down our 5. Now, again, if we ever wonder, we can do this mentally after a while, but 12x divided by 3x is going to be a 4. So 3x times 4 gives me 12x. A negative 1 times 4 gives me a negative 4. Now the rule is, as you put this line here, you're going to change the signs. This cancels out, and this becomes a negative 1. So your answer then, as you put it in MathLab, will be this, and then you're going to say a negative 1 over 3x minus 1. And I'm sure they have it here, right there. Now, notice here they put plus a negative 1 over this. That's good. That's a good way to do it. You could also put the negative here, and then that would just be a plus 1. That's a good way to do it too. Okay? So either way, MathLab will give you credit. Let's do example 5, the practice. I've set it up, and again, doing this physically, keeping records of it in your homework log is going to be a very useful item to help develop practice toward mastery. So 2x times what gives you this? Now you could do it the other way, or we just know it's going to be 2x. So 2x times 2x gives you 4x squared. That's what you want to get. Now 1 times 2x gives you a positive 2x. Notice there are like term columns. Now our rule is, as we draw that line, I was a little fast there, we're going to change our signs. So this cancels out. This becomes 6x minus 7. Now 2x goes into 6x 3 times, because 2x times 3 is 6x. That's what we want to do. And then 1 times 3 is 3. And again, changing signs. This becomes a negative, this becomes a negative. This cancels out, and this becomes a negative 10. So our answer is this. Now, instead of putting a negative there, I could put a plus, as they did above, and it would be a negative 10 over your divisor here, 2x plus 1. Okay, and again, you'll be doing some, so you'll have practice as well. Okay, example 6. Now, here we're going to be dealing with strategy to the first. So, the protocol for setting this up is to put it in descending powers, and if there's a missing value of x, you put it in as a placeholder, has no value, but just 0x. Now, we do our division. So 2x goes into there, 4x squared times. This gives me 8x to the third. 3 times 4x squared is plus 12x squared. We're going to put our line, change our signs. This becomes 8x squared plus 0. And 2x goes into there. I got to put my sign there too. Negative. A negative 4x times. So 2x times a negative 4x gives me a negative 8x squared. And that's what we want. And then 3 times this is a negative 12x. Again, our line, change signs. It's nice when it's the opposite, makes a nice thing. This is 0. This will be a 12x. And we bring down our 7. Now 2x goes into there 6 times. And this times this is 12x. This times this is a positive 18. Put our line, change our signs. This cancels out. We're left with a negative 11. So our answer is this plus a negative 11 over 2x plus 3. Now you could have put a negative there and kept this positive, but this way is the way they're featuring, so that's what we'll do as well. Now example 7. Notice that in our divisor there is no x to the first power. So what they're going to do there is put in a 0x. Doesn't have any value, but it helps to keep the sequence of events straightforward. So again, I could write it out. It is all listed there. The key to this one is that, and your remainder now is a little bit tricky. It's 2x minus 2 all over this. Example 8. Well, here, notice in our, what would be this here, our quotient, I believe, or something, one of those words, there are two terms missing, x to the second and x. Putting them in, again, going through our process, it's all listed there, we end up with this. In fact, let me do practice number 8 for you. So our x will go into there, x squared. X times x squared is x cubed. A negative 2 times this gives us a negative 2x squared. And I see I'm making a little error there because I didn't copy that right. I'm taking this one, but it should be a 3 down there. And I'm glad I caught that right off the bat here. Okay, so this part's the same. This should be a negative 3. That's better. Now we put our line, and you need to check your work. Change our signs. Now x goes into this 3x times. So now x times 3x is a positive 3x squared. 3 times this is now a negative 9x. And we didn't bring down our 0x, but that's okay. Now the rule is we put our line, change our signs. This becomes plus 9x. We bring down our negative 27. X goes into there 9 times. 3 times x times 9 is a positive 9x. A negative times this gives me a negative 27. And I apologize for having to go into this. Let's get the blue. Let's get the red here. This cancels out as we change that sign. This cancels out, and there is our answer. They worked it out for this. And by the way, this is something in our next course we'll be looking at. This is the difference of perfect cubes. The difference of perfect cubes factor into this and this. If you multiply this times this, you get that. If you multiply this times this, you're going to get this and that. So the difference here of perfect cubes. Now there's also one that's called the sum of perfect cubes. That factors. And it's very similar to this, just a little bit of changing of signs. We don't cover that. I just thought I'd mention it. Something you'll be doing in your next course. Okay, that will wind this up. I'm going to do some additional lessons because I kind of like doing this and have it as a reference for you. And but anyway, you're going to get your test on 4-5 and then your final exam. So hopefully you're up to date with your study plan, your quiz-mes, your mastery points, and you're going to do very well on your test and final exam.